Hey guys, my name is Vivek Sharma. Today we can cover this interesting problem that's called implement queue using stacks. So let's say we have been given some of the stacks or one or two stacks, but we need to design some data structure that even if using stacks we can implement the queue functionality, right? So when I say about the queue functionality, for example, let's follow this example that has been given like 1 2, and then it's returning the peak that's returning 1. So let's try to see it here. So let's say I'm having a stack only, I don't have queue, right? And if I insert stack in 1 in the stack, and then another element is 2, and then another element is 3, then my 3 is on the top, right? But when I do the pop, when I do in my data structure my queue dot pop, then apart from 3 it should return 1, right? But not 3. So to solve this problem, if we are having only one stack, then we need to do some trick and around that how to do that. But if we can just maintain two stacks, then what we can do essentially, whenever we are popping, what we can do, we can take another stack and we can just empty this stack. Let's say this is one stack number 1, let's say this is stack number 2. We can just empty this stack here. So let's 3 2 1, right? So on top this will be 1. So whenever we will be popping, 1 will be our output. We can just straightforward return, okay, this is the peak, stack 2 dot peak, that's our output in the stack dot pop. So this is the approach that we can take. So let's try to create a couple of placeholders. Let's do two stacks, and then let's try to do the push and pop here. After doing that, we will come back again to cover some of the edge cases as well, right? So let's at least create a couple of placeholder. So let's say this is stack integer, let's say this is stack 1, and let's say this is stack integer, let's say this is stack 2. Let's initialize this stack 1 equals to new stack here. Okay, let's do stack 2 equals to new stack. Okay, so I have already taken two stacks, right? As we have seen here, this number 1 stack we just use in the post, right? So we don't care about the post, we can just use only one stack. So whenever we are doing the post, let's do stack 1 dot post is x, right? That's it. So while popping, we need to do this thing, right? So we need to pop. Whenever we are doing popping, then we just need to empty stack 1 to the stack 2, and then on that top, that will be our result, right? So let's do the same thing, right? So let's say we need to fill our stack 2. So just make sure that stack 2 is already empty, right? So let's say if it is empty, then what we will do, we will just check like if while stack 1 dot is empty, while stack 1 is not empty, then in that case let's go ahead and fill stack 2. So stack 2 dot post, we will do stack 1 dot pop, right? So in this way we are just popping the stack 1. So the same thing, let's say I have 1 2 3 in the stack 1, and then I'm just popping all these stack 1 to the stack 2. So now 1 is on top, right? So what I can do, if after doing all this, I can just return stack 2 dot pop, that's it. And just to make sure that I don't have empty stack 2, so I will just check if stack 2 is not empty, right? If stack 2 is not empty, then return, otherwise return -1. Okay, so this is for the pop operation. Now let's consider, let's go back to the whiteboard and let's see, like if I don't pop, right? If I just do the peak, right? So I just did the post, now I just do the peak, right? So let's say I don't have this stack, another stack, now I have only one stack 1 2 3, and now what is on the peak, I have still on the peak is 1, right? So I need to do the same operation for the peak as well. So this was for pop, right? Pop, and this is for the peak. So they are the different diagram but the same functionality, right? The same approach. So 3 2 1 for peak also I need to do the same thing, and on the peak 1 will be on the top. So literally I need to copy the same code here in the peak as well. So I did the same thing. and let's go ahead and do the same thing here as well. So stack2 dot is empty, right? So if stack2 is not empty, then what I will do, I will just return stack2 dot peak. Otherwise I will go ahead and return -1, right? So I'm just doing the same thing. I'm not doing anything different in the peak and pop. Now let's consider the case now. So this is just simple push pop and push plus peak, right? Now let's mix some of the test cases. Now let's mix push and then pop and then peak, and let's see how it's going to behave, right? So let's clear the board. Okay, and let's say I have 1 2 3 in this stack, right? And now what I did, I need to do the pop operation, right? So I just empty this stack here. Now I did the pop. So pop I did from, so this is stack number 1, this is stack number 2. I remove the pop from the this stack 2, right? And if I do the pop, then I removed this first element, right? Now I did the push again. Let's see. Okay, so this stack is empty now. So this stack is empty because I filled all this in the step 2. So now I inserted, I pushed another element, that's, let's say, 5 to the stack 1, right? So if I inserted 5, and if I do the pop, right? So in the pop I still have the 2 element here second, so I will just return 2. Why I will return 2? Because of, as per my condition in the pop, I am just checking like if stack 2 is empty, then I am only uh, filling stack 2. If it is not empty, I am not really doing anything, right? So 5 will still be on the stack 1, but it will not be on the stack 2. So I will still, I will have 2, so I will be just returning 2 it from here. And similarly, if I am pushing another element, let's say 6, so stack 1, so let's say this is stack 1, right? So now I am having 5 and 6 in my stack 1. Okay. And 2 I already popped. Now if I do the peak, so peak will also return the 3, right? So we are good for the peak as well. And let's say if I do the pop again, then I still will returning with 3 from here. And now if I do the pop again, now the stack 2 has been empty, right? So now in that case, now I will fill the stack 2 whenever doing the pop. So 6 and 5. So if you see the pattern here, the important point to remember or just to observe is here, then whenever the stack 2 is empty, then only we need to fill that stack 2. If we are not checking that condition, then it will be problematic, right? So till stack 2 is having some elements, don't touch stack 2, because we want to make sure that we are popping up all the elements, or we are just doing all the pop and peak operations until stack 2 is having some elements. And if we don't consider that, if we just, if we cannot mess up step 2, basically stack 2 with the multiple elements, and we want to make sure that stack 2 is consistent, and if it is empty, then only we are filling, and that's the only way that we can make it consistent, right? So this is the important point that I just wanted to walk through. And when it will be empty, when both the stacks are empty, right? So let's say if we consider this scenario when 6 5 is there, but still stack 2 is empty, but still we are having the element, right? So stack 2 is empty, but stack 1 is still having some elements, and we did not do any pop, right? So if any of the stacks are having element, then it's not empty, right? So let's say if stack 1 is empty and stack 2 is empty. So if you observe, this code is exactly some common. So let's move to this, to the some common method. Okay, so just so that we can reuse this again, we don't need to really uh, have the boilerplate code at the multiple location. So I'm just calling this common method from here and there. Let's quickly check the compilation error, if any, and if there is not any, then probably we can just try to submit this and let's see how it goes. Okay, so this is working fine. So I hope this was little clear, and apart from that, from the time and space complexity wise, because we are maintaining Actually, so you know what, the time complexity and space complexity will be measured based on the operation. So let's say the push operation, still we are doing the AND operation, and for pop and peak we are still iterating the elements, right? So it will be the linear complexity in the time complexity, and the space complexity will be the N. So the linear complexity, N is the number of the elements, and if even if there are two stacks, there will be still be N. So N plus N is 2N, and then it's again result as the N itself. So the one important point to solve this problem, you have to remember that you have to make sure while doing this pop and peak operation that stack 2, you need to make sure that you have that check that stack 2 is empty, then only you are just filling stack 2. If stack 2 is still having the element, you need to use the stack 2 only for pop and peak operation. So stack 1 is only for push and stack 2 is only for pop and peak, and if we are following this pattern, then we should be good. But if you are messing up with the stack 2 for the pop and peak, then it will be problematic and it will give the incorrect result. So this is the important point to solve this problem. Hopefully this was useful. Thanks a lot. Have a good one. Bye.